actually probably the toughest one out here. It's like a double layer. There's a couple more things going on there that I want to worry about right now. So let's go to number 2. We'll do number 1 tomorrow. Number 2, my concern here is that you don't know. If I give you the diagonal of a square, can you tell me the area? Diagonal is 10. What's the area? Anybody? The area is 1/2 times the diagonal squared. You guys learned that over? Geometry or what? I mean, it's not, well, like it seems like it's you, I guess, but. So, you know, if I give you a square and tell you the diagonal is 50, the area, well, I don't know why I picked a freaking gigantic number, but it'd be 1/2 times 50 squared would be your area. So, when I'm reading through this, hypothetical square shrinks at a rate of 25/2 meters squared per minute. So this square is actually getting smaller. And the whole idea behind these is as that square gets smaller, what dimensions are changing on it? Well, it's not just the area that's changing. The length is changing. The width is what's the square, so the length is the same. The diagonals are changing. If you think about like throwing a rock into a pond, you know, the circles that come out. What's changing as time passes? The area, the circumference, the radius, the diameter, like all these things change based on time. So that's where that dt comes in. It's like as time passes, what's the change? What's happening? So if I'm reading through this, I'm going to first just kind of start labeling things. So a square shrinks at a rate of, so meters squared per minute. That tells me 2 things. The meter squared tells me that this is area. And the per minute tells me what? That's a rate. So this is dA dt. That equals, and it's negative 25/2. Why is it negative? We're decreasing. So the area of this square is getting smaller as time passes. At what rate are the diagonals changing? So is that d or dd dt? dd dt sounds weird, but that'd be the change. Rate of change, the rate of the diagonals of the square changing. Is that d or is that dd dt? dd dt, because it's the change in the diagonals. And that's what I don't know. What would the label be on that? Meters per, this one's minute, but yeah, meters per minute. And what they do tell me is the diameter, so d, or diagonals, sorry. D is what? 8. Questions on where I'm getting those 3 things. This is 2 things I know, and then what I want to know. This would be, if you want to look at the labels, meters squared per minute. This would just be meters. And now from here, your job is to find an equation that relates the variables that you have. So, you know, if you have area and radius, you're going to use pi r squared for a circle. Here I have area of a square and diagonals, and so this you have to know this formula. So when you see diagonals and areas, so this is the formula I'm going to start with. Is this a equals 1/2 d squared? But what I want to get to is plugging in rates and velocities and changes. So what do I have to do to this original level equation to get to the level where I can worry about rates and velocities and derivatives? I should take the derivative, right? So I'm going to go down a level from here. Now you got to think about when you're taking the derivative of something. The derivative of a is the rate of change of a. How would I write that? What's the rate of change of a? dA over dt. So the rule becomes whenever you take the derivative of any variable, you multiply it by d whatever over dt. So if you take the derivative of an r, you multiply by dr over dt. If you take the derivative of a v, you multiply by dv over dt. If you take the derivative of the MCIS, you multiply by dMCIS over dt. Like whatever variable you're doing, we want to know how it's changing when we go to the derivative level. So the derivative of A is really 1, right? Then you multiply it by dA dt. So what's the derivative of 1 half d squared? It would just be d, wouldn't it? But I took the derivative of a d, so what do I have to multiply by? dd over dt. I want to take a second to review what all these variables stand for. What does A stand for? When I'm done. Leave me alone. Wait, no, what? Okay, stop. I can't talk with your hands. I thought you were with your head down. Just gonna leave it there while you what? Okay, what do you want?
Why did you multiply it by dd dt even though like you did the 2 times the 1 half and cancels its d?
So it's like a chain rule thing. So this. Do you remember what we did? Did you just call me annoying? We're fighting. Remember we did implicit differentiation, and whenever we took the derivative of a y, we multiplied by dy dx?
Yes.
So that's because of like an implied chain rule, where this d, it's like its own function, and so when this is chain rule, you took the derivative of like the big guy, but then this represents the derivative of the little guy is technically what's happening. But we want to be able to get to, okay, this level is amounts, this level is derivatives, and so that's another reason that comes up in this help. Alright, I want to go back through and I want you to tell me, what does this variable represent? Area. What does this one represent? The change in the area. That one? What's the diagonal, right? It's the distance of the diagonal. That's also the distance of the diagonal. What's that? It's a change in the distance of the diagonal. Is this an amount or a rate? Amount, amount, rate, amount, rate. Alright? Let's say, so this is in meters. Okay. Yeah, that was creepy. Okay. So what is dA dt? We can actually put numbers in. Negative 12, let's put negative 12.5. What is D? Hey. What is dt? I don't know. That's what we're trying to find. How do I know I'm trying to find that? At what rate are the diagonals changing? That's what I'm looking for. Now you got an algebra problem. Are you guys good from there? Negative 12.5 divided by 8, and you should be good. Right. I want to set up another one though. I'm pretty sure you can handle the division part. Go to number 4. Talk weird too. Passion. Doesn't even make sense. I want you to try. Here, let's do it together. We're gonna do it together. I want you to try stuff together. Spherical snowball. So we got a snowball. Not every snowball is a sphere. You pack a snowball as a perfect sphere every time? Well, this one's perfect. Man. Okay. A snowball is decreasing, so the snowball's melting, right? But as the snowball melts, like there's more than one variable that's changing. The volume is getting smaller, the radius is getting smaller. If we wanted to get into like surface area, like all these things are changing as it passes. So it melts so that the radius decreases at a rate of 4 over r. So they throw this in here too. So radius decreasing, is that r or dr dt? Dr dt equals negative. Why is it negative? We're decreasing, and it actually equals negative 4 over r. So it's related to the radius. Well, what's the radius if you read through? 2. So what's dr over dt? Negative 2. So you have to plug in something from later in the problem. It's not that big a deal, right? So keep reading. At what rate is the volume changing? So am I looking for volume or am I looking for V or dV dt? Looking for dV dt. When the radius is 2. So r is 2. got a sphere, and I want the volume of it. Do you guys know the volume of a sphere? Volume of a sphere is 4/3 pi r cubed. This is the amount level or the rate level? This is the amount level. I want to get to the rate level. How do I do that? Take the derivative. So what's the derivative of v? dv over dt. So derivative of v is 1, but then you multiply by the dv over dt. And then the derivative of 4/3 pi r cubed. So pi is just a number, remember? So you bring down the 3 and you multiply it by the 4/3 pi. Wouldn't that just give you 4 pi? Because the 3's will cancel. And then you reduce the power by 1. But I took the derivative of an r, so what do I multiply by? dr over dt. I want to go through the variables again. What's that one stand for? Volume. Radius. Change in volume. Radius. Change in rate. That does sound like a cold now. So now I can plug in. The dv dt is what we're looking for, so there's nothing to put there. Like now it's just plug and chug. What's r? 2. And dr dt was -2. And now you just calculate. So 2 squared is 4. 4 times 4 is 16. That's -2. So this is -32 pi. What would the label on it be, or what's the units? So inches cubed. Why is it cubed and not like squared or regular? So it's volume. Volume has 3 dimensions. And then per second. Why is it per something? Because it's changing. It's a rate. Alright, let's go to 5. Do you want to try it, or you want me to do it? Still me? Okay, totally fine. Hypothetical cube shrinks at a rate of this. So, if the cube is shrinking and it's meters cubed per minute, so that's a clue also. What is equal to 8 over v? What would I label as blank equals 8 over v? No. dv over dt. Good. It's negative. Why? It is shrinking, and then it's 8 over v. So that's a problem that we're going to have to address eventually, because I don't know what v is at this point. I can get it eventually, but I don't know right now. Where v is the volume of the cube, so I'm going to need that. So I'm going to put that v there just to make a note I'm going to need it. But what rate are the sides of this cube changing? If I call a side of the cube x, how would I write the rate at which that's changing? Dx over dt. If the side of the cube is x, and I want to know the change in that, wouldn't it be dx over dt? Yep. No, it'd be over dt. If you said L, it'd be dl over dt. You can call it whatever you want, and then it's over dt.
So to do the derivative of y, right? Y over dx or y prime, is that for graph?
That is when time is not involved in the problem. So that's the difference. That's how you know it means. You see time going. And so what am I going to say is equal to 3? X is 3, right? dx dt is what I'm looking for. And I don't have this volume, but I would say we do. Do we have the volume? Do we have enough information to find the volume? What's the volume of a cube? Length, width, height, but if they're all the same, isn't it just like the length times the length times the length? So length cubed, so if a side is 3, what's the volume? 27. So then what's dv over dt? -8 over 20. No. Yeah, -8 over 27. Yeah, I'm good. V is 27. Now, I need an equation that relates all this stuff, which we kind of already used. What equation relates the volume of a cube and its side? Or its side? This kind of just said it. Length comes with the height, but they're all the same. So can't I just go, okay, that's just x cubed? Is the volume? Right? Is this level here the amount level or the rate level? Amount level. I want to get to the rate level. Take the derivative. What's the derivative of v? derivative of x cubed would be 3x squared, but I took the derivative of an x as time passed, so what do I have to multiply by? Dx over dt. And now it's plug and chug. Like the calculus part's done. Yeah.
So you only have to multiply by dx dt or something when it's time interval. Because like when we did the derivative of x cubed before, it was just 3x squared.
Yes.
So it's when time.
Yes. So these are related rates problems, so they'll give you like a thing that is changing as time passes, and that's how you know to be doing this process. But from here, I can just plug in, right? So this is negative 8 over 27. X is 3. So this would be negative 8 over 27 equals 27 times dx dt. So to get dx dt by itself, no, because the 27 is going to go to the bottom. You have to divide by 27, so it'll be negative 8 over whatever 27 times 27 is. So it's 749. What's 27 squared? 720. What's the label on that? That is the rate of change of the length. What'd you say? Meters per second, right? Or meters per minute, the way they did the problem, but that would be a rate. Give me thumbs for that problem. Up, down, middle. Okay. I want you to try 6 and 8. That's it. Let's do 2 problems, 6 and 8. Check those tomorrow. Then there's some like trickier ones that we'll get into tomorrow also.